In this lesson, we're going to be looking at determining side lengths using a different law now, using the cosine law. In the last two videos, we looked at solving both sides and angles using sine law. This is a different law that we can use, and it also has to deal with different types of given information at the beginning of your problem. So we're going to focus on applying the cosine law, explaining how to use the cosine law, and describing how the cosine law is used in problem situations. The outcomes we're going to cover are: solve a problem using the cosine law when a diagram is given. So I'll remind you what cosine is. If we have this right triangle here, triangle ABC, cosine is equal to, let's label it first. If you recall from our video on sine law, angle B is the right angle. So the side opposite the right angle is always labeled your hypotenuse. Side AB does not touch angle C at all. So in terms of angle C, which is the angle we're going to be looking at here, in terms of angle C, side AB doesn't touch it at all. That's considered the opposite angle, or opposite side, I apologize. And side BC is one of the two sides that make up the angle C. So it's not the hypotenuse, but it does touch side BC, or touch angle C. So this is going to be called the adjacent side. Okay. In a situation like this, the adjacent side is always the one that touches the angle, but is not the hypotenuse. And adjacent means touching, or side by side. So for cos of angle C, cos of angle C is going to always be listed as adjacent over hypotenuse. So once again, our adjacent side this time is BC, and our hypotenuse is AC. So cos of C is equal to BC divided by AC. So the cosine law is also used, like the sine law, is also used when triangles are oblique and not right triangles. So remember, oblique triangles are triangles that are don't contain a right angle in them. So these are a couple of examples of oblique triangles. Neither triangle contains a right angle. The one on the left is an acute triangle, and the one on the right is an obtuse triangle. So we can find the length of a missing side in a triangle if we know the other two sides and, this time, the contained angle. The contained angle is the angle between the two known sides. So if we look at this example here, we know a side, we know an angle, and we know a side. And we can go in order from our known values. We have side, angle, side. Just real quick, I'll draw this out again. When we did sine law, we would know a side. We would have known, say, side, and a side, and then an angle. Okay, so that's the difference. The angle in this case wasn't contained between the two known sides. So this is not what we're doing this time. We're doing side, angle, side triangles. So our cosine law looks a lot different than the sine law. It's a law that relates all three side lengths of a triangle with the cosine of one of the angles. The relationship is, for this triangle here, triangle ABC, with sides little a, little b, little c, opposite our angle measures again. If we want to find the length of A, we're going to use A squared equals B squared plus C squared minus 2BC cos angle A. If we wanted to find B squared, and we knew A and C, or if we wanted to find B and we know A and C, I should say, we'd use B squared is equal to A squared plus C squared minus 2AC cos angle B. And if we are looking to find side C, we can say that C squared is equal to A squared plus B squared minus 2AB cos angle C. you may notice that the cosine law looks a lot like the Pythagorean theorem. We've just got an extra piece of information tacked on at the end of it. Also notice that if we're looking for a given side, we're using the cosine of the opposite angle. If we're looking for side A, we're looking for we use the cosine of angle A. If we're looking for side B, we use the cosine of angle B. And if we're looking for side C, we use the cosine of angle C. So let's solve a triangle. Let's find the missing part. So in this case, I want to find side C. I know side A, I know side B, and I know angle C. This is our SAS triangle from earlier on. I want to find out what side C is equal to. So when I'm doing my cosine law, I'm going to write it in terms of side C. So in that case, it's going to be C squared is equal to A squared. C squared equals A squared plus B squared minus 2AB, the same two sides are repeated, times cos angle C. So we use all of our known information on the right-hand side of our equation here. So C squared is equal to 6, oops, it's equal to 6 squared plus 15 squared. Apologies for that. I was having a little bit of technical difficulties with my pen. 6 squared plus 15 squared minus 2 times 6 times 15 times the cos of angle C, which is, in this case, 45 degrees. Okay, we can actually put that right into our calculator as is. And I'm going to go to my calculator again. Okay, so I'm going to type in 6 squared plus 15 squared minus 2 times 6 times 15 times, now in this case, I'm going to type in my angle first, if you recall from our sine law videos when I'm using the calculator on the computer. 45 cosine. So when I hit equals, it gives me 133.72. So I've typed it all in one step, which is perfectly acceptable. So now I've got C squared is equal to 130, oh, I'm having trouble more with the pen, 133.72. Okay, but that is C squared. Up to this point, everything I've done has been to find C squared, but I want to find out what C itself is. So in order to do that, I'm going to have to, if you recall from doing Pythagorean theorem in previous grades, when I want to find C by itself, I'm going to have to get the square root of both sides of my equation. So the square root of C squared is equal to the square root of 133.72, and there was more decimals, I should include those. But that's good enough for what we're doing right now. So that means that C is equal to the square root of 133.72. And once again, I'll go quickly to my calculator. Okay, so at this point, I still have 133.72 on my calculator. All I have to do is hit the square root button, which is in the just below the m minus in the far right, like on this calculator, that is. Find your square root button, and it gives me an answer of 11.56 or 11.6. So that means that my value for C is about 11.6 centimeters in length. Okay, so we're going to use that now to make an example. A tunnel for a new highway is built in a straight line through a mountain in northern BC. To determine the length of the tunnel, surveyors choose a point where they can see both ends of the tunnel. Their measurements are shown below. Use the cosine law to determine the length of the tunnel to the nearest tenth of a kilometer. So we can see a triangle here representing how long the tunnel is. We don't quite know what the length of the tunnel is right now, but we know how far away our surveyor is from both ends of the tunnel, and we also know the degree that the surveyor makes with each end of the tunnel and his current position. So we're going to start by drawing a simple diagram to model this situation. So this is the same information, and we've got our triangle labeled, this time triangle DEF. We know angle F is 65 degrees. We know side E is 2.5 kilometers, and side D is 5.2 kilometers. Once again, we have an SAS triangle, because angle F is contained within angle E and angle D. So in this case, we're looking for side F. We're going to set up the cosine law in terms of side F. So we have the two sides. We're going to use cosine law. In this case, here it is. F squared is equal to D squared plus E squared, because they're the two sides that we know, minus 2DE cos angle F. Once again, in the past we've been using A, B, and C, but we're still doing the same thing. We're looking for side F, so the angle we're measuring, or we're using, is the opposite angle, which is angle F. And we must also know the other two sides. We use D and E here, and we use D and E right here as well. So we know D is equal to 5.2 from our diagram, E is equal to 2.5 from the diagram, and F is equal to 65 degrees from the diagram. So we fill those numbers into our cosine law. And here it is. F squared is equal to 5.2 squared plus 2.5 squared minus 2 times 5.2 times 2.5 times cos 65. So this was D, this was E, this was D, this was E, and this is angle F. So we plug that all into our calculator. We just type it in exactly as is written. Off in your square button is that x squared right there you can see on the screen. So we type all that in, we get f squared is equal to 22.301 and a bunch of other numbers. Okay, so if I want to find f now, I've got f squared. What I have to do is get the square root of both sides once again. So I'm going to get second function and the square root button. In some calculators, the square root button might be a button on its own. However your calculator works again, you have to be able to figure that out for yourself. So f is equal to the square root of 20. So I'll write that out as an extra step over here, just to remind you. F, oops, once again, pen troubles. So f okay, hopefully I got my pen trouble fixed. F is equal, apparently not. Hold on one second. Okay, third time's the charm. We got f is equal to the square root of 22.301. Okay, which works out to giving me this answer in the end. So I just put my value back into my original problem. So the tunnel has a length of about 4.7 kilometers is what we've discovered. And if this diagram, this triangle seems to be drawn to scale, so it kind of makes sense that 4.7 would be right, because it's clearly longer than the side DF or side E, and it's shorter than side little d, so 4.7 seems reasonable. So to summarize, the cosine law is also used, much like sine law, it's also used when we don't have a right triangle, or in other words, we have an oblique triangle. We can find the missing side length for cosine law if we know two sides and a contained angle. No need for two A's there. If we know two sides and a contained angle. So they're called SAS triangles. The cosine law, depending on which side you're looking for, if you're looking for side A, is a squared equals b squared plus c squared minus 2bc cos angle A. B squared is equal to a squared plus c squared minus 2ac cos angle B, or c squared equals a squared plus b squared minus 2ab cos angle C. What's important to note here, depending on which one you use, all we're worried about is what side are we looking for? We must know the opposite angle, and they go together. So side A goes with angle A, and B gets repeated twice, b squared and a b there, and C gets repeated twice. The two known sides get used in the ratio twice. So it doesn't matter what the letters are necessarily, as long as the unknown side and the angle go together.